right, so in this lesson, lesson 2.3, we're going to talk about the law of conservation of energy and matter. So there are a couple rules when matter changes into energy, and maybe one day when we figure out when energy changes to matter, so that happen in this universe. So we need to understand how matter and energy always work together. So to understand this, we need to know something called the law of conservation of energy and matter, and sort of the law of conservation of energy as well, but mainly the law of conservation of energy and matter, because this is the newest rule. Okay, so a reminder from the last lesson, lesson 2.2. Right. We know that matter can turn into energy. And specifically in chemistry, we know that matter or chemicals has chemical potential energy that can energize stuff. Right. But before we start messing with changing matter into energy, there are a couple of rules that we need to understand. Specifically, just one. Right. So all of this, we can see that there's chemical potential energy because it's a chemical reaction. We're mixing two chemicals, making one or more new chemicals, and they're all moving and creating heat, so it's creating some sort of kinetic energy. So oftentimes when we consume food, right, we also feel more energized and able to move more. Right. So that's one way that we can see energy through the foods that we eat, right? So let's talk about the rules. So the law of conservation of energy, it's a long name, but basically it says that energy cannot be created or destroyed. It can only change forms. So whatever energy you start with is the only amount of energy that you have. You can't create more energy. If you have 10 energy thingies, you can only get 10 energy things out of it. Right? No more, no less. We can see this in full force if we ever try to swing a bowling ball, right? So let's watch this video and just observe how the law of conservation of energy is at work here.
Guys, who likes a good game of bowling on a Friday night?
I like bowling.
I love bowling.
So in this video, they're going to do a challenge where they're going to swing a ball, and we're going to see if it hits someone's face.
Stay there a sec. Just get this bowling ball. Dom, just hold that. While I just set up here with a dinosaur. Just watch the dinosaur and see how much he likes bowling.
Okay.
Oh no, poor dinosaur.
Anyway, Dom, could you just stand here for me?
No.
Yeah, please, Dom, just come and stand. I just want you to hold this.
Okay, I'll hold it, yeah.
Stand there, hold that.
Yeah.
Okay. I want to demonstrate a fundamental principle of physics known as the conservation of energy. The fact that energy cannot be created or destroyed. Okay. Can you pull that up to your nose? That's it. Right up to your nose. That's it. Put your head up straight. Oh, let's go chin.
All right.
That's good. Just there. Now, Dom. When you let go of it, some of that energy is going to be converted to moving energy or kinetic energy, okay, as it starts to move. Okay, then it's going to keep going all the way up to the other end of its arc, where it then gets back to having maximum potential. Back down again, maximum kinetic, up to the top, maximum potential.
Greg.
So I'd like you to,
Greg,
release the ball.
All right, so here's the question though. When he releases this bowling ball, is he going to get hit in the face with the bowling ball? What do you think? Right? And maybe you can sort of start to understand the definition of the law of conservation of energy that's at play right now, or maybe you have no idea, but maybe after you watch what happens with the bowling ball, you'll understand this law of conservation of energy a little bit better. All right, so let's see what happens after we place our bets. What's going to happen when this dude, Greg, releases the bowling ball?
are you serious?
Yeah.
What now?
In the name of science, Dom.
Are you holding my head in
Man up.
case it hurts?
Yes.
Greg, I'm scared.
And let go. Hands down. How good is that?
Oh my gosh, he didn't get hit in the face. So at the end of this video, he also explains the same thing. But this is also true, right? Because energy cannot be created or destroyed, if you let go of a bowling ball at this distance from your face, right, and you let it go, it can't swing past where you were holding it in the first place, right? So if Greg was here and he let go of the ball here, it's not going to hit him at all, right? But if Greg was standing where the bowling ball was and then let go again, the bowling ball is going to go back and hit him in the face. But since his face was like right here, just past the ball will not have enough energy to go past the point that it started. That's what it means by energy cannot be created or destroyed, right? You can't put in more stuff. Like if you only have 10 gallons of gas, you can only go as far as 10 gallons of gas can take you on your vehicle. You can't go past that, right? It's basically what it means in general. So in chemistry, we use matter a lot, right? So we added to the rule a little bit and we made this name of the rule even longer. So now we call it the law of conservation of energy and matter. So this law states that the total amount of mass and or energy in the universe does not change, right? So this means that if I take firewood and I'm burning all of the firewood, then afterwards, the ash that I have left should be the same mass as the firewood. And you might think, wait, Ms. Kwan, that's not true. If I take firewood and if I burn it all, it's going to be a lot lighter than it was before. Where did all that matter go? Well, all of that matter just went into the air. So when you're burning wood, you're creating carbon dioxide or the smoke that you're breathing in. So that weight, that mass went up into the air. And you also create water vapor, right? But it's so hot that you can't see the water vapor, and that also goes into the air. So a lot of the weight or mass in your original firewood when you're burning it goes up into the air as carbon dioxide and water vapor, right? So if you really think about this, this is kind of a weird thought, right? Or a weird rule of our universe. It basically means that everything that ever existed in this universe is still here, but just in a different form. So all your past ancestors, every single star in this universe, including our sun, all of the atoms that made up that stuff is also a part of you. So maybe one of your atoms used to be a star, or it used to be part of a dinosaur, or something insane, or part of an asteroid, right? Everything in this universe constantly is getting recycled from energy to matter, from matter to energy, right? Okay, so that is the main law you need to know, the law of conservation of energy and matter. Basically, nothing gets destroyed. What you have before is the same as what you have after. So if you have the mass of something before, like if the mass of this campfire was 10 grams, afterwards, the mass of the ash and all the carbon dioxide and water vapor in the air will also be 10 grams. So mass and mass don't change, matter and energy don't change. What you start with is always the same as what you end with. And that is the law of conservation of energy and matter.